Hello, I'm Richard with EV4U Custom Conversions, and welcome to another episode featuring the 1966 Porsche 912. In this episode, we're going to update you on what we've been doing, the progress that's been made in the engine compartment, as well as some plans for under the bonnet. So let's take a look. So what we have is things are fairly the same looking as far as from our last episode where we had components in place, but now things are pretty much wired up with the exception of our interconnects for our battery cells. So to sum things up, we have our two saddle racks in the back, 12 cells each for a total of 24 in the rear here. This is our most positive point in our complete vehicle traction pack. So this is the most positive point, comes up here to our service disconnect, and from here it goes to our main contactor as well as to our lead that runs up front to where our battery charger is. We have our main contactor, we have our relay here that controls it, pre-charge resistor on the back side of our component board here. This then goes to our Curtis 1239 controller or inverter, and to our motor, and then this is the negative side of our pack. The most negative point in the pack is in the front battery pack, and so it goes through that pack and comes out over here to the saddle rack on the right side of our motor, goes through that pack, up and across, through our pack, and back to our most positive. We also have our cooling system in the rear here. That's our coolant reservoir. We showed you and talked to you about the path and so forth last time. So since we spoke last, we've filled the system with the 50-50 mixture, coolant and water, and tested it. No leaks at this point, but the true test is after it's been on the road and you heat things up and you build a little pressure. We also wired up our terminal strip here, and what we have are our throttle inputs here. This is our 12 volt input to the controller. This is, and that's a switched 12 volts. This is a switched 12 volts that is being used to operate our fans on our cooling system as well as the pump. So when you turn on the ignition key, the pump and fans come on. And then these are other inputs for such as this relay and other controller inputs. Now, what else we have going from the rear of the vehicle to the front is we have, of course, our most negative line that runs up to the front pack, and then we have the return line, which is from the most positive of the front pack, comes back here and goes to a negative here, our most negative in the rear. So we've got those two high voltage lines that run front and back. We have a couple here we talked about that come from a fuse block up front, which we'll show you. Those are both switched 12 volt lines. We also have two lines that run forward that go to the menu switch that operate the Curtis display and programming for the controller, as well as the pigtail that runs to the Curtis display. And so that's pretty much it that runs from front to rear. The other thing in the rear to take note of is our throttle. This is our throttle cable. There's a couple pulleys that run to a mechanical piece of linkage that's stock on the Porsche, and that then is connected by cable up to a linkage that connects to the throttle pedal. It has a built-in return spring. We always add a secondary return spring, just kind of that redundancy on certain parts of a conversion that we like to include, and that's one of them. If that stock spring were to break, we're covered. You don't want to have to use your emergency disconnect switch if you don't have to. So anyway, that pretty much wraps up the back here for what we've done since our last episode. Now, what remains to be done is we have a cover for this. So this is all covered. That's already produced. I'll just lay it in place here real quick. It fits kind of like this. Anyway, that will cover the cooling and so forth, so that heat basically won't be rising up. The fans blow down. They blow through the radiator and the cooler. Got good airflow, works well. The rest of this will be bringing air in from underneath, comes in here and it exhausts out through the deck lid. So it should have a pretty good breathing engine compartment. So what's left to do in the rear is we need to install our interconnects, which will be one of the last things that we do. And then we need to make the covers that will go over and be part of the cell containment. We also have the and this is just a piece of it. It's not been cut to length. It's just a piece that we have laying around that I want to show you. But we have these cell booties from EVTV that will be cut, fit, that will go over each one of the terminals, and then the cover goes over that. So they're kind of shock mounted into place, insulated, and contained. So that's it in the rear. And once that is done, you know, the rear is completed, ready to roll. So let's take a look at the plan for up front. Okay, here's under the bonnet. So all of this red loom that you see, this was in the car when we received it. That's not part of what we're doing. But here is what we're doing. We have a front battery rack which contains 20 of our 44 cells. We have the shunt that's just behind where you can see here in the smuggler's box. We have, and that is our most negative leg, of course. And so this leaves here, goes through a fuse, through our shunt, and to the rear of the vehicle. This is the most positive cell in our front pack. Again, it goes through a fuse and goes to the rear to the most negative cell in the rear that we showed you a moment ago. So, in addition to the 20 cells that are housed up front, we also have the auxiliary battery, and this is going to stay in the stock position. So the front driver's side corner right here. We have our charger. These things are just setting in place. They still need to be mounted and wired up. We're just kind of showing you what the layout's going to be. Next to the charger we have our DC to DC converter. You notice it's real close to the battery. And so we have a line from our most positive terminal in the rear that we brought forward earlier that we showed you. This is going to go to a terminal that, from that terminal, we will take our feed for the DC to DC converter, our input. We also will take off from there and provide power for our heating element for the heater, as well as that's where our charger will tie into the system also. And then on the proper side of the shunt, we will have the negative for all these things on our pack voltage connections. So we also, in addition, this is not really part of a conversion necessarily, but we typically add it. And this is a little battery minder trickle charger that will go right here. It's set up so that whenever you are charging the vehicle, that it will be charging the auxiliary battery. Whenever you have the ignition on, your DC to DC converter's then turned on, and it will be charging the auxiliary battery. And those two methods are sufficient for keeping the auxiliary battery fully charged, always ready to go. Now, say you're going to go on a long trip or something, all you have to do is run a separate extension cord to that. You unplug it from our safety interlock, which I don't have installed, but I'll show you later on. But that allows this to be maintained for an indefinite period of time. But under normal use, it's plugged into our little junction box that we plug the charger into, as well as our little battery minder. So everything's pretty much no thought, turn the key and go. So what else do we have up front here? Well, we talked about our 12 volt stuff. So let me show you that real quick. So also under the bonnet here, we have our heater. It's a pretty good size one. Dual element ceramic heater to provide heat. It's tied into the stock defrost setup and also ducted down to the feet. And then this side, which is not connected right now, goes to a vent on the passenger side to blow on the passenger's legs or wherever. It's an adjustable vent. And then here's what we were talking about. This is a couple of fuse blocks that we've added. And what we have here then is on this side, this is an unswitched fuse block. In other words, we're taking 12 volts directly from our auxiliary battery and running it through a fuse and then to a fuse block, where we can pull off 4 individual unswitched 12 volt circuits. Then we have a relay which will switch on our DC to DC converter. So whenever you turn on the ignition, our DC to DC converter will be turned on. You turn off the ignition, the DC to DC converter is turned off. We also have a power relay. And that power relay is the only thing that we're pulling off of the stock fuse block. And that is, we're pulling 12 volts switched off of the stock fuse block. And that then turns on our power relay, which then energizes this fuse block with 6 auxiliary circuits. We have 2 plugged in right at the moment. And so whenever you turn on the key, this fuse block is then energized. And one of these goes back to the controller. It's the 12 volts input to the controller. But this 12 volts can be interrupted along the way. It goes through our JLD 404 through one of the relays. It goes through our inertia switch. It goes through our safety interlock. And so all of those, and through our emergency disconnect in the dash. So this 12 volts to energize the controller can be interrupted. All those items are in series, and any one of those will disable the vehicle. So if the vehicle's plugged in and being charged, our safety interlock disables the vehicle. If for some reason you wanted to activate the emergency disconnect, makes a good anti-theft device even. That disables it. If you're in a collision and the inertia switch is energized, that disables you. Or if our pack is fully discharged, or not necessarily fully discharged, but discharged to the level that we're going to allow it to discharge to, then it's disabled. And then the other line here, this one, is what's operating our fans and pump in the rear for our cooling system. So very simple, straightforward, as with all of our designs. It's just clean and simple, allows for easy troubleshooting, but in our experience, you won't even need to troubleshoot. By keeping things clean and simple, we have the reliability and dependability that we like in a vehicle and a conversion. So what's next? Well, we're going to mount those components under the bonnet. They'll be mounted in place, and we'll wire them. So everything will be wired. All of our high voltage and low voltage circuits will be wired. Basically what's left to wire up on the high voltage, it's high voltage, low current circuits, and then the 12 volt control circuits. We need to run, we have a 12 volt gauge that we've installed We need to wire that, the emergency disconnect and the safety interlock, all that like I discussed, all that still needs to be wired up. Our JLD 404 needs to be wired. And so basically all that's in the front end of the vehicle. And so that part will be done as soon as those few components are mounted in place. We'll wire it up. We'll do the last, we've tested the fans and the pump and that type of thing, but we'll test all of the 12-volt circuits in the front end of the vehicle then, make sure all that is working. And once that's completed and everything's tested and satisfactory, then we will start installing our interconnects. And as our policy, we will leave one of the middle ones out, and we'll connect all the others, and we'll be doing voltage checks along the way, and everything is double checked to make sure that we've wired up our traction pack correctly. And once all that's confirmed, we'll install the last link, which will then give us one completed traction pack, series wired pack of our 44 cells. We should have a nominal voltage. Well, when we first hook it up, we'll have a nominal voltage of 2.75 volts times 44. And so once that is complete, we will jack up the rear end, do a quick test to make sure that the motor and controller and everything is working. Once we have confirmation that we have power and everything's working, we will then, before we do a test drive or anything, we will then charge the pack. And so that will take a little bit of time. Once the pack is completely charged, then we'll go for a road test. So we'll be back with some views of everything wired up and completed. Perhaps if we catch it, we'll video the spin up, and then of course we'll take you along for the maiden voyage, the road test. And so we'll install some GoPros and take some footage of the initial road test. So I hope you'll stay with us, and we'll be back. So here's a quick shot of the engine compartment with the battery cells with the interconnects in place. We removed the insulated strips over the interconnects so that you could see it wired up. So basically the back end is complete. The only exception being our covers, the tops for the battery boxes. We still have to make those, but we'll be making those as we charge up the battery pack. So here's a shot with the insulated covers in place, or strips, and then our cover will go over those and hold the cells from any movement up and down. So that acts as a cushion as well as an insulating barrier. Let's take a look at the front. So here's a shot, the front end, our front battery pack. You can see we're missing one interconnect. And originally we had left one out of each rear pack also. while we're wiring it up, we always leave out like the middle link. And so that's our last one to put in place now that everything's wired up. I think last time we talked, we hadn't mounted any of the front components in place. So now we have our charger, our DC to DC converter, our trickle charger for our auxiliary battery. And so it's about ready to rock and roll here. We need to put the cover on these cells, put that last link in, charge the pack. Once we charge the pack, then we're going to program our charger and be ready to rock and roll. Another item that we didn't have installed last time is our inertia switch. Our heater is now wired up. We showed you the fuse block, are unswitched and switched. So everything is about ready to go. A little bit of cosmetics and so forth, but for the most part, it's about complete. So here's a shot with the insulating strips in place on the front pack. Again, we have some covers to put on, but other than that, she's just about ready to rock and roll. So now we need to plug it in and charge up our pack. Well, as things will go sometimes, we had a little issue. The original charger that we installed in this vehicle didn't work. And so we placed, you can see it down below here. So we just have this one sitting on top of it right now temporarily, just because we wanted to get the pack charged. So once the pack is charged, we'll pull this out and swap them and return the other one. But you know, you kind of think things are going to go a certain way. It's a brand new charger out of the box, factory fresh, and so when it doesn't work, you're checking to make sure that you didn't do something wrong, that everything is the way it should be. And so we couldn't figure out anything else other than that it was the charger. It's doing everything else right. The light code flash is correct. Everything was fine. It just wasn't putting out any current. So we left it in place, and once the replacement came in, we stuck it on top of it here and just plugged everything in, and bang, takes off, starts charging. So just a bad charger. Like I said, you know, brand new out of the box item. Kind of a disappointment. Added some time to our big picture. But the good news is we now know what the problem is and have it rectified. And so we now just have to swap it out. Unfortunately, you know, getting to the mounting bolts and everything is a little bit of a pain. But we'll take care of that and move on. So once the pack is charged, we can do additional testing.